So today we are going to solve the problem Leetcode problem 1065. The name of the problem is the minimum initial energy to finish task. So it is the problem of the day. So let's see what is given in the problem. So we have given a 2D array whose name is task, and each of the task values contain the two values, which is actual and minimum one. What does the actual and minimum values represent for a particular uh, given task? So actual value is the actual amount of energy which we require to spend in this particular task, I am task. And what is the minimum energy required? Minimum energy required, minimum is the minimum energy required to begin a task. So there it is something like a threshold value, which is the most it is a cutoff value, which we need to satisfy to start a particular task. Let's see one example. Suppose the task value is given as 10 number. In that case, if we have energy created on cell total, in that case only we will be able to start this task. Otherwise, we will not able to start this task. So suppose if we have as our current energy is 11, so we will not able to start this task because the minimum energy required to start this task is 12. So in the case, if we have our current energy is 5, in that case only we will able to start this task. So this is example for a particular task, and it also mentioned the problem that we can finish our task in any order. So it will depend on us in which order we want to finish our task. And what we have to do is that we have to find we have to return the minimum initial amount of energy we will be able to finish the all the tasks. So we have to find the minimum initial energy and using it we will able to finish all the tasks. Suppose let's see one example. Suppose this is an example in which the full task are given and the initial and the minimum value is also given. So in the case we have that is our outside update. So if we perform our task in the suppose the as we can see in the explanation part of this problem is the lesson in which order in which the all the three tasks are performed are first they perform the third task, so that they perform the second task, and then they perform the first task. So if we perform our the task in this order, we will be able to finish with our initial energy value was 8 value. Means this will be the minimum value. But if we suppose if we perform our task in this order, from first we perform our first task and second then third. Now let's see what will happen. As our current energy is 11, which is greater than the minimum energy required, so we will be able to perform this task. So now we will subtract it. One from it, we will get our current energy as 7. When we turn to the second task, in this case, our current energy is 7, but the minimum energy required is 4, which is less than that of our current energy. So we will be able to perform the task as well. Now, our total energy, our current energy will become 7 minus 2, which is 10. Now, when we come to the third task, in this case, we can clearly see that the minimum energy required is 0, and our current energy value is left only as 5. So in this case, we will not able to perform this task. So with the same value, with the same initial energy, we will not able to perform all the tasks. We will perform our task in this order or in the order of 1, 2, and 3. So from this analysis, what we came to know that is that the order of performance of task is very much important in deciding the minimum initial energy which is required. So this is very important. So first we need to decide the order in which we have to perform our task. So from if we analyze the second and third problem as well, we will came to know that we have to perform those tasks earlier which have the greatest difference between their minimum and the initial value of their energy. Suppose as we consider the difference between the actual and the minimum energy required for this task is 4, which is greater than that of all these two other task value. Because the difference between the third task is 4, and the difference between the actual and the minimum energy required for second task is 2, and that of first is 1. So we have to perform our task in the order in which the absolute difference between the actual energy to the minimum energy of a particular task is greater. So we have to first sort this task in the order in which the difference between the absolute value the absolute value of difference between the actual and the minimum value will be greater. So from the analysis of the first three problem, we will came to know that we have to sort this our task value in a such a way that the absolute difference between the actual and minimum value will be greater. And we will come to know that from this analysis we came to know that in which order we have to perform our task. Now the second problem arises that how we will came to know that the rate is the minimum crucial amount of energy which we should have to perform all the tasks given in the problem. So if we will see this problem is that this problem is related to a binary search because it is a monotonic function. Because suppose if we have any value greater than or equal to it, so all the tasks we will be able to perform. Because if we are able to perform our with value 8 with our current value at current value as 8, we will be able to perform all the tasks. Yes, so all the values greater than or equal to 8, definitely we will be able to perform all the tasks. So if we have value as our current value is less than it, in that case, we will not able to perform all the tasks given in the problem. So it is actually clearly a binary search problem. So what now let's decide the start and limit of the start and end value and parameters of a binary search. As start we can have a minimum as 0, and what will be the end variable in the binary search will be. So if we see that our task length vector has a length of 10 to the power 5, and the value in which the range of the values of the actual and minimum will lies in the range of 1 to the 10 to the power 4. The maximum value of end can be 10 to the power 5 into 10 to the power 10 to the power 9 is the maximum energy which we could have to solve a particular problem. So the uh, the start value will is the initial value of the start will be the 0, and the initial value of the end will be and variable will be the 10 to the power 9 in our problem. So let's solve this problem. So first we we need to maintain one valid function which will check for a particular given value whether they perform all the tasks or not. So we have to look at one variable. And then we will find the length of this the task. Oops, okay. Then we will iterate through all this print will do the evaluation and calculation. Okay. If our value is greater than or equal to our current task minimum value, in that case, we will perform, we will set out our task with I count 0. Otherwise, this condition not satisfied, in this condition we will return false, we will not able to perform. And if all the tasks were completed, in that case, we will return the true value. Okay. So as I have mentioned, we have to sort our function, sort our task given. So we have to sort this. So we will task dot size, task dot bigger, and after that we have to sort task dot end. But we have to task in a is it not sort in the regularly what we do because sort will sort this task based on the first value only, means based on the actual value of a particular task. But we have to not sort based on this actual value only. We have to sort based on the difference between the difference between the minimum and the actual energy required. Absolute value. For that, we need to make one comparator function. So we will make one comparator function here. Here, do comparator function. Okay, and in which we will pass our two vectors. Suppose it is vector 1 and and constant for and vector in vector. Okay. So we have to sort in decreasing order. So in that case, we will sort based on the absolute difference between the vector 1 uh, I and vector 1 v greater than or equal to absolute value of vector 2 minimum value minus vector 2 actual value. Okay. So we have sorted our head. Now, as we have made our function valid, which will check for a given particular value of our for a given particular current energy, whether we are able to solve all the tasks or not. So this particular function gives that result. So and now let's start our as we have I have already explained what will the start value. Start value is 0, and what will the end value, which will start, which will be the 1 e to the power 9. And we will make one variable answer, which we will have to we will store the till now the minimum value which we will get and minimum value of energy which we have there. which is able to solve all the problem using which we are able to solve our problem. So we start our start lesson equal to maybe after that we will find here it will be the start plus minus s by t. Okay, and after that we will store the result from which we get from the is valid function whether we are able to solve this problem or not. After that, if we get the result, if we get the true value, in that case, what we will do? We will store our answer as the minimum of already answer stored to that of mid. And what we will do is in this case we will decrease our end to mid minus one. Else, if you are not able to solve, so in that case we will increase our start value to mid plus one. So till now we will return our answer as answer which we have stored. Let's see. Let's run this problem. This particular program it is one. So, okay. One problem is going the fonts that comparator. Yeah, okay, okay. The one is spelling mistake is there. Okay, so you consider the all the test cases are passing. Now let's submit this problem. Okay, percent. Okay, we now accept it. If we can see here, we accept it. So, thank you.